All right, so we're back now in our series of dealing with this student class. Recall we created it, we separated out into a .h and a .cpp file. And now I'm going to talk about adding another class that basically contains student objects, contains a collection of student objects, okay? So this actually begins to get at one of the core principles of what we're going to be talking about in this class. This idea of a class that is really used for sort of holding a collection of other things. Okay, that's the idea of data structures, right? So here, what I've done is, and that's also why I've given the assignment that I have, because it kind of walks us down that pathway. Okay, so here. What I have is I've created this roster.h and roster.cpp. Okay, so let's go ahead and take a look. Here's the roster.h file, right? So I created this just the way that I created the new class in the last video. Okay, and you can see, so a roster basically has a vector of students. Has a vector of students called students, right? We have a constructor. We have a way to add individual students. We have a way of searching for students by their name. Okay, and I also I also am writing an output operator here to kind of help us see kind of what's going on and all of that. Okay, one quick note now, is that this find is just slightly different from the find that you have to implement in the current assignment, right? Your find doesn't return a student reference; it actually returns sort of a copy, with the idea that if it doesn't find it actually sort of returns this student object that is a degenerate object, right? Or I'm sorry, a word entry that is a degenerate word entry. Okay, here, just for simplicity's sake, I'm going to return the student itself, and we'll kind of see how we go about doing some of this after. Okay, in roster.c++. All right, I've already written the output operator. I didn't want to spend a whole lot of time kind of talking about it and writing the code and all that, but I will just kind of walk you through, what this does. So basically, so I'm going to output an open curly brace, and then I'm going to copy almost all of the elements, everything but the last element, because of course when we copy using this method, what happens is every single one of the elements is going to be followed by whatever we specify here, namely the semicolon space. So I don't want a semicolon, the sort of separator following that last one. So that's why I'm doing end, basically copying to end -1 right here. Okay, then we come down here. As long as we have at least one student, we're going to actually output basically that last student followed by a space, and then we output the curly brace. I just realized that's an error there. That should in fact read Oster. And finally, we return the output stream. Okay, so that's all that's going on for our outputting. All right, let's take a look at the rest of these methods. Okay, so again, just like we did before, I'm going to grab these, copy them, and I'm going to just paste them into here. Okay, and once again, like we needed to do, I'm going to go ahead and make sure to to put in the scoping, right? So yes, it's the roster constructor. It is the add method of roster, and finally we have the find method of the roster class as well. Okay, so those are the things that we need to implement. All right, and then I'll just start by adding in some empty implementations like this, and we can kind of take a look from there. Okay, so The roster constructor, its job is, again, to initialize the default state of things. Well, it turns out we don't have to do anything with our only instance variable, the student. The vector basically gets created by itself. Its no argument constructor is going to be called automatically, and that's fine for us. So we don't have to do anything here. So, I'll just kind of shorten this up like that. There we go. We're done. Right? So nothing else to do with that roster constructor. That's kind of the nice thing about some of these types of classes where you're delegating some of the work to other things, right? The vector is actually going to do a lot of the work for us, so we don't have to worry about that. Okay, now adding a student. Okay, adding a student, really, really simple, right? So again, you might want to, if you haven't already looked at it, just to do a quick Google search, say for something like C++ vector, right? And again, you can kind of come up and take a look. Hopefully. All right, there we go. Right, and we can see there are a number of different methods here, right? And of course, we see there's the good old pushback method, right? Adds an element to the end. That's what we want, right? So there's already a method there for doing it for us. All we have to do is delegate the work to it. So we go to the students vector and we call pushback, and basically we just add the particular student. That's it, right? Couldn't be any easier. Okay. Now, again, in your assignment, you're given two values that you then have to wrap into a word entry. Okay, but that's a very, very small extra change to this. It's pretty close to what we have here. Okay, let's talk about finding a particular element. Okay, so we want to be able to find if a student exists with a particular name. Okay, so there's a whole bunch of ways we can do this. Okay, in the worst case scenario, right? If you went through those videos on vector and all those higher order functions and everything, and they just hurt your head. In the worst case scenario, basically, all you need to do is just write the code sort of the old-fashioned way that you would before. So, I can use sort of the old nasty C-style for loop, right? Basically just saying, okay, well, so I is equal to 0 while I is less than, so we'll say students dot size and I plus plus, right? We can do that. Okay, and then all we have to do is inside here, if it's the case, right, that, let's see, so if it's the case that students, and for accessing an individual element in a vector, I could use sort of the array notation, right? Honestly, I'm not going to do that because there's a better way of doing it with vectors. Remember, the at method does pretty much the same thing as using the square brackets, except the difference is if this one goes out of bounds, you're guaranteed to get an error. Okay, so that's one way of improving your code a bit kind of cheaply. Okay, so I'll use at as opposed to the square brackets. Okay, so if students at let's see, and then we're going to call get name. If that's equal to, well, the name that we're looking for, then we return that particular student. So students at I. Okay, there we go. And yeah, let's see. Yeah, I'm returning a constant. Right, we're going to get there in a minute. You know what? In fact, what I'm going to do, I'm going to actually change this slightly. Because here's the thing, with this particular loop, so the idea is if I find a match, okay, I return that particular student, right? But suppose, so let me just do this, end of the for loop, okay? Suppose I get here. Suppose I don't find a match. That is, we don't have a student like that. What am I going to return, right? So the way this is set up, I have to actually return a reference to a student. So I'm actually going to switch this up back, make it a little bit closer to what, whoops, what was that? There we go. Make this closer to what we have in the assignment. That is, I'm going to say we're going to have to return a student, and we're just going to return a student by value. Then we don't have to deal with this whole const stuff and all that. And again, then what I'm going to do is I'm just going to come in here and I'm going to make this little student constructor that looks like this. So we'll say something like name is empty, and GPA is -1, right? So there it is. I've inlined that directly into the student header. Of course, in your assignment, you have actually a separate implementation listed in student.cpp. Okay, but there it is. So I can create this sort of degenerate student, right? A student that doesn't have a name and has a GPA of -1, right? And really the whole point behind doing that is it just makes writing this find a little bit easier. Otherwise, I'd have to kind of return some other type of thing, maybe an iterator, maybe a pointer to something. So this makes it just a little bit easier to deal with. Okay, so again, now I'm going to return the student. I return that back out. Basically, it's a copy. We don't have any issues there. Now, if we get down to here, basically what we know, we've gone through all of the students and didn't find what we were looking for. So if we didn't find what we were looking for, then all we need to do is return that. That is, I call that new constructor that I implemented that basically returns that degenerate student. Okay? So there, we've written some code there. Now let's actually play around with this, try this out, see what we can do. Okay, so I'm back over here in main, right? I have my 2 student objects. You'll recall I can print those out, etc. But let's actually do this, right? So now let's create a roster. And we're going to need to include roster.h. All right, let's see, there we go. And then we can add our students, right? So I can say add S1 to the list, and I can say add S2 to the list, right? Like so. I can then print out the roster, and we can see what we get. Okay. So notice, there's my roster. The first student that we entered in was Cecilia. There's the second student that we entered in, Sam. Now, let's take a look at searching for individual students. So we can do things like, I can say, okay, roster.find, and I can search for Cecilia. Right? So if I do that, I'm going to get this, right? Basically, it goes through, it finds the first element is, in fact, Cecilia. Let's try it out for Sam. Right? So we'll see if we can find Sam. And sure enough, let's see, we run this. Yeah, we can find Sam. Okay, let's look for somebody who isn't in there. Let's look for Max. Okay, we don't have a Max inside there. So in that case, yeah, notice we get our degenerate student. Looks good, right? So it is working the way it should. Okay, so right there, I mean, that's enough. You could just be happy. Find is working. You're great. Okay, but if you're like me, you look at this kind of thing. I know I'm not really supposed to do this. I'm not, this isn't the greatest code. He talked about that sort of for each stuff and all that. There's got to be a way of kind of fixing this and doing that. Yeah, there is. Okay, so let's take a look at that, right? So I can rewrite this code to use for each. Okay, so again, if I come back over here, and if I remember right, let's see, we can go to other, and for each is in algorithm. Okay, there are actually there's a couple of different ways. I can use the individual for each function. Let me show you even before doing that, right? So one quick way we can change this code. And what I'm going to do is I'm going to copy this and paste it in. That way, if you decide to access the code later on by going to the link in the show notes, you can actually you can kind of compare the different codes, right? So remember, C++ has this style of loop as well, right? Where we can say we can use auto, and we can say, okay, student in students, right? So there it is. Okay, there's C++'s for each loop, right? So I don't have to worry about individual indexing and all that. Now, how does the rest of this stuff change? Well, it becomes simpler is what it does, right? So notice I don't have to do students at and all that. I can just say, look at, get the name of that particular student, compare it to the name that was sent in, and if that's the case, then I know that I can return this student. Boom. Okay, there it is, using the for each syntax of C++. And again, let's make sure that our code still works, right? So when I run this, let's see. Yep, looks like I broke something here. Let me go back. Yes, I am missing that. Was missing my closing brace for that. There we go. All right. So we'll go back over here. Once again, I'm going to run this, and yeah, we still found Cecilia, we still found Sam, and Max still isn't in the roster. Okay, good. So we've improved the code, but not broken the code. Okay. Again, there was the for each function, right? So notice, for each, it's apply a function to the range. Realistically, that's not the best fit here. In fact, now that we're in algorithm, I want to point out something else. How about this? Find an element in the range. Let's take a look at that, right? So find if kind of sounds like what we want to do. Right, so we see, okay, it takes an iterator an input iterator at the beginning, an input iterator at the end, and a unary predicate. Okay, unary predicate's just a function. All that is, right? It says it's a unary function, meaning a function that takes a single argument, right? And returns a value that's convertible to a Boolean. Okay, basically returns true or false. All right. Let me show you what this looks like in practice. It's really not that, it's actually very, very easy. Okay, so once again, I'm going to come over to here, and I'm going to comment out that code. Okay, so let's see, do we have algorithm? No, we don't. There's the algorithm header. All right, now let's come down here and work at sort of that higher level. Okay, so find if, we said, takes a couple of things. So first we have to specify the beginning of our range, okay, which is just call begin of students, and we're going to go to end of students, and then we need our function. Okay. Now I could define it directly here. I'm actually going to do it kind of in two steps just to make it a little bit easier to read. Okay. So I'm going to use the auto keyword. That way I don't have to worry about all the exact syntax for defining what the function is, right? So I can just say this is my name match function, okay? And it's going to be a lambda, right? So we already know our lambda syntax, right? We have our square brackets, we have our parentheses. The parentheses are for arguments, okay? So in this case, the idea is that the name match function is going to be called automatically by find if with elements that are in the students array. Well, what are those kinds of elements? They're students, okay? Now, again, C++ is actually smart enough to figure that out, so you could actually just do something like this if you wanted to, or you could be explicit about it, saying, yeah, I'm actually going to, I know that I'm going to get a student, but either way is fine. Okay, and then we can have the body of the function. Okay, so the body of the function, basically, what we want to do is see if the name of the student is equal to our name parameter. Okay, so we come down here and we do that. Now, there's a problem with this. See, is it picking? It isn't picking it up there. All right. Okay. Oh yeah, it's actually still complaining there. Okay, so now that we have that, let me go here and say name match FN. Okay. So we have that. Let me go ahead and build this, see if we can get it to kind of give us an error here. Yes. Okay. Error, use of auto. Let's see. So there's use of auto and lambda. Yes, right. So, okay. First of all, if I am going to use auto there, they are right. I do need to bump my my C++ version up to C++ 14. Okay, there we go. And I should have done that before. Yes, enable auto reload. There we go. Okay, so now that's going to take a minute to load up and do all of that. Great. Okay, back over to here again. Let me do a quick clean, and let's build this thing. And yeah, sure enough, we're getting some more issues, etc. Right? Notice it doesn't like me using name here. Okay, and basically here's the idea. So if we take a look, right, we can use student because that was actually one of the parameters that's sent in, but name isn't actually, it's not one of the parameters, it's not a local variable, it's a variable that actually is outside here. In fact, it's a parameter to find, okay? So officially what we're trying to do is create a closure, okay? That is, we're trying to close over this variable name, okay? This section here is for closures. It's for variable capture. Basically, we can list those variables that we want to capture in our anonymous function. So since I want to be able to use name, which isn't declared inside the anonymous function, I can place that right there. And that basically tells C++, hey, look it, I'm going to use this variable. I know that it's actually from outside, and I'm going to actually make use of that. I'm going to capture it to make use of it. Okay, so again, let's make sure that that compiles. And sure enough, it does. Okay. Now, one other thing about this, it doesn't really affect what I'm doing here, because what I'm actually saying here is that I'm creating a copy of name. If I wanted to use name directly to even be able to sort of modify it inside this anonymous function, then I'd want to do it by reference. So I could put the ampersand in front of that to do it by reference. Again, I don't need to do that here because all I'm doing is checking to see if student's name matches that particular name. Okay, so now that we have that, let's go back and take a look at the documentation for findIf to see how we're using this, right? So it tells us that it returns an iterator to the first element in that range for which the predicate returns true. Okay, so in other words, if it does actually find a match where the student's name is equal to the name that was passed in, it returns an iterator. Again, we're not going to worry about the whole type stuff. I'm just going to do something like this. So I'll call it student it, like so. Okay. So we create this student iterator. It's not actually a student. An iterator in C++, basically they were built to act like pointers. Okay, so you can think of this as kind of a special kind of pointer to a student. Now, if it's able to find the student, that's great. Okay. It's great, right? So an iterator to the first element in the range for which the predicate does not return false. Notice this part. If the predicate is false for all the elements, the function returns last. Basically, that thing there. So that's how you know whether the element actually was in there or not. So this is what we're going to do. I simply say, okay, look at if the iterator is equal to the end of students, right? That was my last. Then I know that I wasn't able to find a match. On the other hand, if I did, if the iterator isn't at the end, then I know I actually found the correct student. So what I need to do is the same kind of thing that I would need to do with a pointer. Dereference it. Student it, right, star student it, basically dereferences that and gives me the student. Okay, so there's another version, a modified version of looking for the particular element, and this time using the stuff in algorithm. Okay, once again, let's make sure that this stuff actually works. So yes, it was able to find Cecilia, it found Sam, and Max still is not in the roster. Okay, so that should give you a good idea about how to deal with some of the additional functions, how to think about kind of solving all this stuff. And again, if you got questions, just shoot them to me.